You may know by now that OpenAI has released two open weight models, and in this video we are going to see what are those models, where does it stand in comparison to other models, and what is the best way to use it to build the application on top of this. So let's start with the models which are released by OpenAI. So there are basically two versions of the model which are released. One is GPT-OS 120B and another is GPT-OS 20B. GPT-120B is a larger model and you can use it for general purpose high resolution tasks, and this has been designed to run in data centers and high-end desktop and laptops, whereas GPT-OS 20B is a lower latency model because this is small in size and this is designed to run in most laptops, desktop and mobile. And these models are not just generic models, these models are the reasoning models, and along with the reasoning models we can also use it for any kind of tool usage. And because these are the open source models, so definitely we can go ahead and do the fine tuning. And you can see the tweet of Sam about the same. The reasoning capability of bigger model is at the level of O4 mini and it can run on a high-end laptops, whereas the smaller model we can use it and run it on phone. Now if we compare it with other models what has been released, and this particular comparison we are taking it from artificial analysis. Here you can see from the intelligence perspective, evaluating it across all this particular benchmark, we can see the GPT-OS 20B high is currently standing over here, and then GPT-OS 120B is currently standing over here. Now if we compare it with other open source model like DeepSeek R10582, so as you can see DeepSeek R1 model is still having higher intelligence than these models. Now if we compare the intelligence with the active parameters, and in this one GPT-OS 120B is falling. And why this is most attractive quadrant, because we are getting higher intelligence in the lowest active parameter. So if we compare it with DeepSeek R1, so in DeepSeek R1 we can see like it is having more number of active parameters and it is having higher intelligence, but here GPT-OS 120 is having the lower number of active parameters but it is still giving the better intelligence, whereas you can see GPT-OS 20B is having the lower intelligence in comparison to all these models. The other parameter what we have to look is intelligence versus price. So in this case also you can see GPT-OS 120B we are getting the higher intelligence in the lowest price, because if I compare it with DeepSeek R1 then it is standing over here. Eventually we are getting higher intelligence with the DeepSeek R1, but the price is also a bit higher. Now let's see actually how we can run these models. So before that I just want to highlight one thing. In this tweet you can see Alex has tried to run this particular GPT-OS 20B model which is suitable to run across most devices. So he's tried to run it on M1 MacBook Pro and it took 21 minutes to produce a response. If you see all the commands what he has used, so it's clearly visible that he has tried to download the models using Ollama, and he has tried to download all this model on his personal laptop, and then he tried to interact with this particular model and it took 21 minutes to produce a response. And that's where the problem occurs. You can definitely go ahead and download this particular model on your local using Ollama, and we have already covered in the past how you can run any open source model using Ollama, and this is good if you want to play around with this. But if you're really thinking to build any kind of application around it, so the latency would be too high. We need a way to cut down all that latency, and that's where the fast inference provider comes into picture. So they would host all this particular open source model and then they will cut down all this latency and will try to give you a response very fast. So in this case there is a comparison between 4 fast inference provider, and whatever you see these are the seconds to first token received, lower is better. So in this case this particular provider is giving the response in 1 second, Groq is giving a response in 4.6 seconds, and then you can see like there are some other providers as well which are giving response in 8.4 and 41.1 seconds. And also on top of that these particular models are also available on Vertex AI and Azure OpenAI if you want to leverage it. But if the speed matters for you, then you can use like any of the fast inference provider. And that's where the pricing is coming over here, because these are the open source model but they have evaluated it across all this fast inference provider. The price what they have listed out over here for these models, these are the average price what they are getting from this fast inference providers. So in this video also we will do see okay how we can leverage this fast inference provider, and we'll try to run these models using these platforms, and the best way to achieve this via Hugging Face. So here we are at Hugging Face page, and you can see we are under this GPT OSS 120B model. And if you see at the right side here, it's mentioned the inference providers, and there are so many inference providers are listed over here. If you want to interact with any of the models, then you can just go over here, type the sentence, and you can interact with it. What we are going to do is we are going to go look into the code snippet. Here at the bottom you can see the code snippet. You can just click on this, and once you click on this, then you can see the inference provider what has been listed out over here. So there is a Groq, Novita, and there are 5 more, and you can just select like any of the inference provider from here. If you don't want to select like any specific inference provider, then you can also go ahead with the auto, and then Hugging Face will try to route your request to a particular inference provider automatically. In this case, I'm just going to go ahead with the Groq one. So these inference provider, like if you want to interact with it, there are 3 options. One is Hugging Face Hub. You can just call it via API call, and this is also OpenAI compatible. So if you know, like if you know OpenAI SDK, then it would be very easy to write a code in the same fashion to interact with these models. So I'm just going to go ahead with the OpenAI one. And one more thing I just wanted to highlight in this case, like if you are selecting the Groq one, then you can see the model name. It's going to change into Groq. If I'm using any of the other reference provider, then it is going to change accordingly. And if I go ahead with the auto one, then you can see like there is no inference provider name mentioned as such. Hugging Face will try to route it to the available inference provider accordingly. So let me just go ahead with the Groq. And one more thing what we have to notice is not all the inference providers are same. So if you just scroll it at the bottom and click on compare inference provider for this model, then you can see like for this particular model what kind of functionality is available in all the models. Wherever you see this tool one, it means it supports the tool calling. This light sign denotes like which one is the fastest. So if you are using this particular model, then you are going to get a response very fast. It's 865 token per second. So this is going to be fastest. If you are using the GPT OSS 20B, then in that case you can see Groq is the fastest, and this is going to produce the response at 977 tokens per second. Considering all this, what we are going to do is we are just going to copy this code, and we would go to our Visual Studio. Here I can just create one file demo.py, and I can just paste this code. Now because we have to use the environment variable over here, so I am just going to create one more file which is going to be env, and under this env we have to pass this hf underscore token. So I will go over here, I will just paste this token. Just to use it, I have to pass Hugging Face token value, and that you can get it from your Hugging Face account. You just need to go to access tokens, and once you click on this, it's going to route you to this access token page, and from here actually you can just click on create new token, and it will create a token for you. So from here you just have to click on create new token button, and it is going to give you 3 options. In this case, you can just go ahead and create the read token. You can give a named token, and then it will create a token automatically. So this particular read option would be enough to make calls to inference provider on your behalf, and that's what we are looking for. So we do not want to give additional accesses to this particular token. The read would be sufficient in this case. So I already have my token generated, so I'm just going to go over here and put my token, and we will go to our code. Here I don't have this particular package installed, so I will just try to install it. So I'm in my virtual environment now, and I will just try to install this OpenAI package using pip install OpenAI. So we have installed this package. The next thing what we have to do is load our environment variable. So for that we are just going to use this, and we can just load our environment variable. We also need to install this particular package, so this has been installed as well. Now we can just save our code, and we can just try to run this. So I will just click on this because we are using this fast inference provider Groq, so you can see how quickly we are getting that response. Even though we are trying to run it on our local, but it's not taking around like 20 minutes to just get a response out of it. And if you just want to get a response, if you are just interested with the content of it, then you can just also navigate till content. It's just going to give the output. So I'm just going to click on the button and just see like how quickly we are going to get this response. And we have got the response. This tells us our basic setup has been done because these are the reasoning models, so you can also invoke the reasoning. If I just navigate like what options we have, so if you just scroll it down, then you can see okay, we do have the reasoning effort as well. If I have to invoke the reasoning effort, if my query is quite complex, then using the open source model also we can just pass it. So with the chat completion endpoint, we just have to pass low, medium and high. Here I can just pass low. So there is a typo, I just fixed it. I can just go ahead and run it, and you can see we are able to get a response. In this particular case, like, we don't need that much reasoning, but because these are the reasoning models, so they can perform the thinking. This would be good for any kind of complex scenario, any kind of coding task, and we can just handle it from here. So it also supports the newer endpoint. As of now, actually, we have been working with the chat completion one, and if you want to utilize the newer endpoint, which is going to be the response API, you can also integrate it with the response API. You just need to change this particular endpoint, and it can support the response endpoint as well. And if you want to know like what are the different features of responses API and how to leverage it, then I will put that link in the description. You can also go over all the videos and you can try the different features which responses API provides. If you are using the responses API, then how you pass the reasoning effort, this is going to get changed. How you pass the input parameter, this is going to get changed. But just wanted to let you know like this also supports it, and I changed it to input. And here, if you are using this one, then how we get the output, that is also going to get changed. So here I can just use the text and I can go and I can run it. In this case also I'm able to get a response. This is how actually you can build a very fast applications on these open source model using all this inference provider. Yeah, and that's all what we have in this video. Thank you for watching.